pseudostratified columnar epithelium. We know we have the air on the outer surface, and you can probably see a basement membrane right around here. The cells are just all over the place, and that's because not all the cells start in the basement membrane, but they all don't reach the air. So the nuclei all appear at different levels, and you've got this really disorganized appearance. Now, also, what you'll see with them, your last name? Yeah, Anne-Marie. Also what you'll see is a very long fuzzy cilia on these. Look at how long these projections are. These are not folds in the surface membrane. These are little hairs that actually whip back and forth like on a sperm, right? Or some of the other critters that you might have learned about in biology class. They just beat back and forth, and if you were able to cut one of these cells free, it would swim away. But they're stuck together, so they're not able to swim apart. Instead, the waving of their cilia causes fluids in the open space to be pushed in one direction. So you find these in passageways where you need to move things along with a delicate beating motion. So they are important in helping move eggs and sperm along, especially eggs in the oviduct, the uterine tube. But the most famous place you find them is in your airway, from your nasal passages all the way down through your windpipe, through all the branchings, all the way out to the air sacs of your lungs. You are lined with this pseudostratified columnar epithelium. And don't laugh, I'm going to do another one of my famous artistic renderings that are really bad. The nose, a nasal passageway, and an oral passageway coming together. We go out to the lungs, we branch pseudostratified columnar epithelium all the way down until you hit the air sacs of the lungs. Now, if we were to blow up an area with the pseudostratified columnar epithelium and actually look at it, you'd see the walls of the airway, and you'd see the cells. I'll just draw a few in with their cilia. And every once in a while, in pseudostratified columnar epithelium, here's an example here, here's an even better example here, you're going to find a mucus cell. There's one there, there's one there, and there, and one. So here's the pseudostratified columnar epithelium, very disorganized, but a single layer of cells. They all start at the basement membrane, but not everybody reaches the top. So this little guy never got very far. These little guys never got very far. But this one did. Look at the cilia up at the top. It's really long. And these mucus glands here are making a carpet of mucus. Very light, thin mucus. And that mucus traps bacteria. Now the way this process works is all these cilia beat uphill. They don't beat randomly, they only beat uphill. So when you breathe dirt, there's a bunch of bacteria right here. Dirt and debris and bacteria, pollen, the tiniest little fragments of garbage that enter your airway are trapped in this mucociliary ladder and beat uphill to constantly protect the air sacs of the lungs. And the last thing you want in the world is to have all that debris get down and land in the air sacs of the lung, where they coat the air sac and you can't move gases across like CO2 and oxygen. So the mucociliary ladder is an escalator that beats uphill to always keep the airway impeccably clean. Now, if you do anything to damage it, you can end up getting really bad lung infections. So if you live in a place where there's a lot of air pollution, and there are many countries like that, or if you live in a city with a lot of air pollution, or if you live in a house with a leaky wood stove where there's a lot of soot, or if you're a cigarette smoker, you are not only gonna be taking a lot of particulate matter into your airway and making your mucociliary ladder work really, really hard, lots of times the substances that you contain include poisons and toxins, notably air pollution and cigarette smoke contains toxins that paralyze the mucociliary ladder and may even kill it. Yeah.
Does mold, toxic mold?
So the mold are particles, and you can beat them out, but the mold produces chemicals that are too small to be moved really effectively by the mucociliary ladder. They're gonna get down in the lungs, they're gonna cross over and into the blood and can poison you. So chemicals are only picked up very lightly by the mucociliary ladder. That job is to really pick up particles, tiny particles of things, which it does really well. But excess heat or poisons or toxins in the air can actually damage the cells of the mucociliary ladder so they become frozen and don't beat uphill, or they actually die back. And then when you breathe stuff into your lungs, it stays down there. And you get a lot of mucus deep in your airways, and you get a lot of infections. This is one of the problems with lifelong cigarette smoking. It gradually kills off the mucociliary ladder, so you don't clear your lungs very well. And then, of course, you're breathing in a lot of smoke, and that contributes to the problem of lung damage, lots of pneumonias and lung damage. I might point out that smoking anything does this. I don't care how cool the smoke is, what you're vaping, it isn't good for your mucociliary ladder. You know, even if it's cool, there are chemicals in the substance you are breathing, and maybe particulates that aren't good for your lungs and aren't good for your mucociliary ladder. So if you're taking a drug by vaping, like medical marijuana, something like that, or recreational marijuana, I would recommend not vaping it. I would recommend eating it. Now, I know that doesn't create the same effect, but especially for medical marijuana patients, it's much better to leave the airway alone and ingest these medicines by way of the gut. Now, this is a top view of a mucociliary ladder, and so you should see, we're going to be looking at it from above, just seeing the tops of each one of these cells. They should all be covered with cilia. But you can see in this electron microscope view that many of the tops of these cells have lost their cilia. And this is what you might see in the first stage of damage from chronic cigarette smoking or cigar smoking or, cannabis smoking. Any smoking or inhalation over a period of time is going to damage the mucociliary bladder. Now one of the last of the tissue types that we're going to look at is our first layered type, the first epithelial cell type where we're looking at more than one layer, stratified squamous epithelium. Many, 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 many layers of fried egg-shaped squamous epithelial cells. So this is a cross-section through your skin or your integument. And the top part is many, 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 many layers of stratified squamous epithelium that ends at the basement membrane. And then underneath it is an area with a lot of nerves and blood vessels, a deeper connective tissue layer of the skin. The top layer of your skin is stratified squamous epithelium. Now, we're going to spend a lot of time learning about how skin forms and grows and the different kinds of skin and all about trauma. But just to generalize right now, when your skin makes new cells, it does because at the very bottom, next to the basement membrane, are stratified squamous epithelium stem cells, baby cells, that constantly divide, and as they divide, they're pushed north towards the air by new cells coming behind them. So in just a few weeks, a new squamous epithelium that made down at the basement membrane is pushed all the way up till it's finally at the air surface. Now, as it's pushed up towards the air, it matures until it has that classic fried egg shape.